In this video, I want to show you an example of how to factor an expression like 4x squared minus 4x minus 3 using AC method. So let's go ahead and let's start by describing under what circumstances we would want to use AC method, because this technique is a little bit lengthy and I would describe it as a last resort. So I would use AC method under what circumstances? I would use it when the A value for the expression is larger than 1 and at the same time the expression has no greatest common factor. If both of these conditions are satisfied, then AC method is generally speaking my only choice and therefore my best choice for factoring the expression. So for example here, we have the expression 4x squared minus 4x minus 3. And let's recall that A is the name that we give this number that's being multiplied by x squared, the coefficient of x squared. So in this problem, A is positive 4. So the A value is larger than 1. And in addition to that, looking at this expression, the numbers 4, 4, and 3 don't have any factors in common that I could factor out. So because of that, AC method really is the only choice that I have, besides just guessing and checking. Now while I'm here, let's write down the values of B and C for this expression. B is what we call the coefficient of x, so the number negative 4, and C is what we call the constant, so that number negative 3. Okay, now AC method consists of about 4 steps. The first thing that we do with AC method is we calculate a product. We calculate the product A times C. That's where this method gets its name. AC method because the first step is to calculate A times C. And then find a pair of numbers whose product is AC and whose sum is B. All right, now let's apply that step to our particular example. We have A equals positive 4 and C equals negative 3. So AC is equal to 4 times negative 3 is equal to negative 12. So our goal is to find a pair of numbers whose product is negative 12 and whose sum is negative 4. So let's check a couple of possibilities. The first one, which is very easy to overlook, is 1 times negative 12. That would have the correct product, but the sum is incorrect. The sum is minus 11. Let's see, 2 also goes into 12, so let's move up to 2 times negative 12. 2 times negative 6 equals negative 12. And let's check 2 plus minus 6 is negative 4, and that's actually exactly what we want. So the pair of numbers whose product is AC and whose sum is minus 4 is the pair 2 minus 6 in this problem. Step 2 is we're going to use this pair to split the term bx. Now let me describe what I mean with this example. we have 4x squared minus 4x minus 3. I'm going to leave the x squared term alone, and I'm going to leave the constant term alone, but I'm going to split the term negative 4x into two separate terms. The first one is going to be positive 2 times x, using the positive 2 from the pair above, and the second one is going to be negative 6 times x, using the negative 6 from the pair above. So take your quadratic expression and use this pair to split the term bx. Now the next thing that we need to do is we need to factor by grouping. Now factoring by grouping, as you may recall, could only be used in circumstances where our quadratic expression had 4 terms. And that was why we split up the second term into 2 separate terms, so that we went from having 3 to having 4. That way we could factor by grouping. Now factoring by grouping says, first, look at the first 2 terms, all by themselves. Look at those by themselves and try and factor out the greatest common factor. Now both of these terms have an x in it. X squared has an x, and x in the back consists of an x. In addition to that, both of these terms have a 2 in it. There's a 2 and 4, and there's a 2 and 2. So the GCF would be 2x in this case. And I have 2x times the quantity. 2x is left behind from the front. 4, take out 2, leaves 2. X squared, remove x, leaves a single x behind. And then 2x, if we take 2x out, only 1 is left behind. So looking at the first 2 terms all by themselves, factoring out, this is what we get from the first 2 terms. Now let's have a look at the last 2 terms. Negative 6x minus 3. What is the greatest common factor of these 2 terms? Well, both 6 and 3 have a 3 in them, and they also both have a minus sign. So I'll factor out negative 3, leaving behind 2x plus 1. Now notice what's happened, and this is very important. The quantity that has been left behind from both the first pair and the last pair is identical. 2x plus 1 was left behind, and 2x plus 1 was left behind from both the first pair and the second pair. So what I'm going to do now is I'm going to factor out that 2x plus 1. That gives me 2x plus 1. Let's write it in the front. 2x plus 1, and what's left behind? What's left behind is the 2x from the first position and the minus 3 from the second position. So here is our final answer. The final answer for this problem is the quantity 2x plus 1 times the quantity 2x minus 3.